Yeah, in this section we'll look at fluids in motion, and study of the motion of fluids is called fluid dynamics. And as I said before, a fluid includes all things that can flow. And typically we think of that as liquids and gases, although I'll show you a video, I'll try to include it in the link, called the pitch drop experiment. And that includes pitch. It's sort of this coal-like substance. It looks like coal, these dark, black, hard objects. And what they do is they take this stuff and they put it into a funnel, these big chunks of this material. They put it into a funnel and they leave it there for many, many years, 10, 20, 30, 40 years. And what happens is, over time, these things drip down and they'll make these little drops, and these drops will come out over many, many years. And so the pitch drop experiment is an experiment, or is just, yeah, I guess that's an experiment, where they've placed a camera on this pitch, which is in a funnel, and you can actually watch it flow. But it only happens over many years. It doesn't happen readily. So you can watch time lapses of this, and I'll post a video of that in the website. So when we're looking at fluid flow, we're going to be looking at ideal fluid flow. An ideal fluid flow will have meet 5 different criteria. First of all, it should be steady, not unsteady. And what that means is the velocity at a point does not change. So if I have a pipe, I will say at this point the velocity is v, and v is always the same. In fact, I'll call that v1. This point is v2. Now v2 might be different from v1, but v2 is always going to be the same in a steady flowing fluid. Second is the fluid should be irrotational. Irrotational means it doesn't rotate. All right, a good example of a fluid that rotates. See if I can do this. You'll see what that is. That's a toilet, right? And so fluid in a toilet rotates. It is rotational. But when we're looking at a flow of a fluid, we'll look at a fluid that does not rotate, that it goes along a straight line. Also, it should be non-viscous. The pitch drop experiment is an extremely viscous material, but a non-viscous will be a material that doesn't have much friction between the molecules. So viscosity So for example, pitch is an extremely viscous material. I'm not even sure that people would even call it a fluid, although that's a good question. Pancake syrup has a high viscosity. Motor oil, a little lesser, but still it's a thick, sticky substance. Water has a very low viscosity. And so when we're looking at materials, we'll be considering fluids like water, for example, that have a low viscosity. Uh, in order to have ideal fluid flow, it should be incompressible. Remember that only liquids are incompressible, that gases are compressible, but liquids are incompressible. Solids are incompressible too, but only liquids. And that means that when you apply pressure to a liquid or to an incompressible material, the volume remains the same. Okay, the next is laminar versus turbulent, and this is a little more complicated. In a laminar fluid, it should be laminar, by the way, not turbulent, for an ideal fluid flow. In a laminar fluid, the fluid flows in parallel layers with no interaction between the layers. The layers near to the sides of the pipe are the blood vessel or whatever, move more slowly. And usually this occurs for viscous fluids because it's like the viscous fluid sort of sticks to the side of the container at low speeds. Most blood flow is laminar. Let me draw a picture of what this will look like. So if this is my vessel, my container, a pipe, or a I don't know, just something where this blood is flowing, it's going to travel in straight lines. It might be slower on this side and faster in the middle, but it will move in parallel layers that don't interact with one another. If I have turbulent motion, these layers interact unpredictably. Velocity of the fluid changes a lot, in fact. And sometimes blood flow is turbulent, such as in, well, do you know where you have a common place where you have turbulent blood flow? It's in the heart. When it contracts, blood rushes quickly into another chamber, or not change, into another chamber. And this causes a very distinct, like swooshing sound. Okay, so those are the 5 properties for an ideal gas. Excuse me, I'm sorry, the 5 properties for the flow of an ideal fluid.